Welcome to the Foundry by Forge College. Okay, so following the materials from our previous module on scalability considerations and deployments, we got deep into forecasting capacity, identifying hardware constraints, and handling those pesky transaction bottlenecks. Well, today we're taking all of that strategy, all that performance and scalability insight, and we're synthesizing it into mission-critical rocket launch prep. We're diving into the synthesis and deployment strategy checklist.
Now, there is a really stark difference in deployment mentalities out there. On one hand, we have subjective readiness. This is what I like to call YOLO deploying, basically running entirely on vibes, right? It's that classic developer moment. You're staring at your code base at 2 a.m., nursing a cold cup of coffee, and you're just like, yeah, I feel pretty good about this. Let's just push it to mainnet. It relies on hope, feelings, and honestly, crossing your fingers that nothing breaks. But contrast that with the real engineering mindset. Objective readiness. This approach, it relies on strict, automated pre-flight checklists based on metrics, thresholds, and cold, hard data. We're going to explore exactly how to move an entire deployment process from simply hoping it works to definitively knowing it is ready. So, here is our official flight manifest for today's explainer. First, the deployment pre-flight. Then, measurable readiness checks. After that, automating the CI/CD gates, mapping goals to strategy, and finally, rollouts and rollbacks. Let's get right into it.
Section 1, the deployment pre-flight, preparing for launch.
Okay, let's dive into this. It's time to prepare our Solana deployment rocket for launch. The pre-flight is really all about identifying exactly what happens to our systems when things get, well, a little too intense. In this phase, we absolutely must guarantee something called graceful degradation. So what actually is that? The source material defines it as the set of specific behaviors your system must exhibit when capacity limits are reached. Think of it kind of like a wildly popular exclusive restaurant. If they're at absolute full capacity, they don't just barricade the front doors, turn off all the lights, and start screaming at new customers through the windows, right? I mean, that would be totally chaotic and ruin the business. Instead, they hand out those little vibrating pagers. It's a controlled, systemic response to being overwhelmed. And why does this matter? Because handing out pagers prevents the kitchen from completely crashing under the weight of too many simultaneous orders. It keeps the restaurant running smoothly for the people who are already seated inside. Your Solana dApp needs its own version of a pager, not a barricaded door. When your RPC nodes get absolutely hammered or transaction volumes violently spike, your system needs to gracefully throttle or queue those requests to maintain overall uptime, rather than just outright failing and leaving all your users completely in the dark.
Section 2, measurable readiness checks, binary health checks. Moving right along, let's transition from those isolated concepts to actually measuring our deployment health. We are taking those qualitative trade-offs we just explored, and we're turning them into binary measured health checks. Simply put, we need acceptance gates. An acceptance gate is a test or metric that produces a binary pass or fail decision before a deployment can proceed. So the crucial point is this. If you have ever been in a war room at midnight with your development team, frantically arguing about whether a sudden latency spike is quote-unquote acceptable, or if the code is ready enough to ship, you know exactly how incredibly valuable it is to have an unemotional exact gate. The gate says pass, or the gate says fail. That's it. It completely removes all the human subjectivity. It eliminates those stressful negotiations. Setting up these strict minimum acceptance criteria beforehand replaces all that deployment anxiety with absolute technical certainty. It really saves everyone a massive amount of headaches when it's finally time to ship.
Section 3, automating the CI/CD gates, machine-readable rules. Now, having gates is really only half the battle, right? We need to automate them so human error doesn't slip through the cracks. The source material outlines this brilliant logic flow for creating a machine-readable JSON deployment profile and a TypeScript checklist script to enforce these rules automatically. Think of this script like a master engineer reading a blueprint. Step 1. The script reads your JSON deployment profile, which contains all your hard-coded requirements. Step 2. It actively runs the checks. For example, it evaluates if your target transactions per second, your TPS, is sitting safely under the network peak. It checks if the expected memory per validator is within the actual physical hardware recommendations of your hosting provider. Then, step 3, it emits simple, indisputable pass or fail results. By writing a TypeScript script that integrates directly into your continuous integration and continuous deployment pipeline, you remove the human element entirely. So if your validators require more memory than your hosting plan actually affords, this script flags it immediately and halts the deployment automatically. You fix it before you fly, not while your application is plummeting back to Earth in a fiery crash.
Section 4, mapping goals to strategy, business to technical. You know, the courses over at Forge College spend a lot of time helping developers prepare to confidently map high-level business constraints directly to technical deployment hurdles. And this brilliantly illustrates exactly how prescriptive we can be with this mapping. If your primary business goal is low latency, your typical strategy is a mainnet staged rollout, and your minimum acceptance gate is, quite literally, that a TPS benchmark passes and meets your target. Simple and direct. Now, if your project is highly cost-sensitive, you start on devnet and you make absolutely sure functional tests pass before you spend a single dime on a mainnet deployment. And what if you have strict regulatory needs? Well, then you look at deploying to a private cluster. Why a private cluster? Because heavily regulated industries often require strict data sovereignty, meaning you have to legally prove exactly where the data physically lives and processes. So, in that specific case, your technical gate becomes an automated data residency check that must rigorously pass before any code is deployed. You systematically map the abstract business goal directly to a binary technical gate. Make sense?
Section 5, rollouts and rollbacks. Safe release procedures.
So, we've mapped our goals, we've passed our automated gates. Now what happens when we actually initiate the launch sequence? Listen, dropping 100% of your traffic onto a brand new deployment all at once is just a disaster waiting to happen. Instead, staged rollouts act as your ultimate safety net. We start at phase 1, a smoke test. This is just a deployment routed to a tiny sample of internal users just to make sure nothing immediately catches fire upon contact with reality. Then, phase 2 is the canary rollout. Here, we send maybe 10% of total network traffic to the new release for about 24 hours while we watch the system telemetry like a hawk. And finally, phase 3 is the full rollout. But get this, we only ever hit that button once our key performance indicators remain completely stable throughout the entire canary testing phase.
But wait, what if that canary stops singing during the second phase? You absolutely must define explicit, automated rollback criteria before you ever launch. For example, you tell the system, hey, if our error rate jumps 20 times over the baseline, or if our latency worsens by 50% for 10 straight minutes, automatically roll it back to the previous version. Now, how do you actually execute that? You hook up these automated rollback criteria directly to your standard Prometheus and Grafana monitoring stacks within your CI/CD pipeline. The pipeline constantly reads the data stream, and if a metric threshold is breached, the pipeline acts as a circuit breaker. It kills the deployment and reverts to the previous stable state instantly. You need to set these specific numerical thresholds while you have a clear, calm head so that you aren't making subjective, panicked choices during a last-minute hotfix anomaly at 3 a.m. when literally everyone is exhausted. If you take away nothing else from today's explainer, let it be this. Subjective readiness conversations absolutely must become measurable, repeatable gates. This is literally the golden rule of deployment. By adopting this rigorous engineering mindset, you fundamentally remove deployment friction, you eliminate all those unnecessary team arguments, and you completely cure launch day anxiety. Okay, to summarize our flight prep, burn these 3 concrete takeaways into your memory. Number 1, make your decision artifacts machine-readable using simple JSON profiles. This really matters because, let's face it, machines do not make typos or overlook configurations during a high-stress launch. Number 2, map your acceptance gates directly to automated tests, like your TPS benchmarks. This guarantees your code actually meets the hard business requirements before it ever sees the light of day. And number 3, staged rollouts are mandatory for non-trivial releases. Always have a mechanical rollback plan. Keep these 3 core principles in mind because you're going to need to prepare a profile artifact just like this for the integrated smart wallet project, which we'll be tackling head-on in our next module on scoping the decision framework. You'll definitely need this exact objective mindset to succeed there. So I'll leave you with this provocative final thought. Are your deployments driven by measurable automated gates, or are you still just hoping for the best? It is time to start engineering your deployments with the exact same rigor and precision that you use to engineer your code. To learn more about this subject, dive into the next lesson and explore our other incredible Web3 learning resources. Visit the website at forge.college. It is your ultimate operational manual for mastering the decentralized web. Thanks for hanging out with us and happy deploying.